welcome to everybody again. I'm Cristiano De Nobili, the lead AI scientist here at PySchool, and welcome to this is the second Tech Talk of session 14 of the PySchool of AI. Today, it's a pleasure to host Manuel Del Verme. Manuel has cultivated a diverse expertise in machine learning, both academic and entrepreneurial, spanning several countries, including the US, Italy, Switzerland, and currently is in Mumbai, but used to be in Czech Republic, if I'm not wrong. Currently is in Mumbai. I think he's taking a couple of weeks off, but you will tell more about it. He was a fellow. No, he was part of PySchool somehow at the very beginning. His work is mainly in algorithm design to enhance human capabilities at the intersection of AI with human needs, and currently is focused on exploring the possibility offered by large language model and large language model agents. In today's presentation, Manuel will talk about how large language models are changing from, let's say, just working with language to acting instead as agents that can handle a complex task, also in a web-based setting. Then we will explore large language model augmented autonomous agents. These agents use a large language model to interact with different web environments. I don't want to spoiler too much, but overall, let's say this talk will give you a full overview of the current research and I think what's coming next in the LLM world. So welcome again, Manuel. The floor is yours.
Thank you. So AI in general has been a very exciting field for for a long time, for at least the last 10 years. And over time, we keep getting something new, and then people jump on it and figure out how to make it work, how to reuse the past knowledge that we discovered, the past tricks for the new thing. And everything keeps getting better and better, right? And so far, there is no stopping to that. And so I think this is just the last iteration of the same type of science and progress that we're going through. LLMs basically give us a way to have a good language model, so just to see what is the next word. Then we managed to turn them into a conversational machine where you can have a nice conversation. And almost immediately after ChatGPT came out, people started to try to give them tools, right? Because just talking with something is not enough. We would like our robots, our agents to interact with the outside world. And so this is one of the ways you can see as the birth of LLM augmented agents. The name is actually we don't agree yet on what is the real name. People call them different ways, but basically an LLM is a language which goes from text to text, right? And a LLM augmented agent is something that has an internal machine, which is cognitive or intelligence, which is the LLM, but also is able to sense the environment, right? And make a plan about it and do something. The environment usually is each other a question and a prompt. So the first thing the agent senses is a task, a request, like in the initial prompt. Then sometimes there is an internal thinking process that really looks like the human one. And then in the end, the action is either give an answer or sometimes using an external tool, like looking up extra information. And so we figured a way to turn this language model into something more, something that can interact with the world, right? And now I'm going to go through all this stuff that we put on top of it, right? And it's going to be a lot, but it's fine. I'm going to go through them again later. So we had this sense plan act paradigm, which is the same one we had in robotics. Then we added tools on top of it pretty quickly. So access to a calculator, access to a web search, as you see in ChatGPT, or nowadays multimodal generation as well. And then we added the ability to replan. So the agent will just think about what to do to get to a solution, but then it would also be able to think of different possible chain of thoughts, right? Sequences, but then remake another sequence after it has taken the first action. And this is important in decision-making and decision-making science in general. So you make a bigger plan of what you're actually going to execute. And then we got like the ability to explore rather than to just go straight to the solution, to try to have different possibilities in your mind and entertain all of them at the same time. And external memories, like external databases. Like people have been trying to put all the pieces together. And the first one I'm aware of, like this is a massive graph just to show you what kind of complex systems they were like AutoGPT and Baby AGI. They came, as soon as the OpenAI API came out, and engineers obviously put together something to look like general intelligence, right? This machine can do everything. In reality, if you played with it, they were very unstable. But that was something that makes you think what could happen, right? It had this complex system of tasks, creation of subtasks, prioritization of them, spawning of sub-processes. All the process was very complicated. And this is what a prompt looks like. Like, it's a lot of stuff, everything together, almost never got anything useful, except for a few demos that people got really excited about. But like this is the end goal. And so like what slowly our field tried to do was to slim down, get what works, slim down the process, get what works, and try to understand how to get smaller and better improvements. So a normal task looks like on the left. We have a prompt, we have a question, and we have an answer. And this is an example for the AI to understand what kind of task is it going to happen. Like, what kind of task do I want the AI to do? So I have a first example question, a first example answer, and then another question, and the model will know that it has to answer. This also works for just GPT-3, not even with the instruction part. Like, just the very basic language model are able to do something like this. But then we figured out that if you put some kind of chain of thought, so some sequence of thinking steps before the answer, in the example, then the agent will figure out that it has also to think about things, like to work out the problem themselves to get a solution. And this increased the quality of the answers a little bit. The issue with this kind of ways is that nothing interacts with the real world. It's just internal in the agent point, like inside the agent mind or latent space, right? So an error anywhere in the thinking process will just create error downstream, and hallucinations are one of these examples. But it was the first way we started to try to think about some planning part of the answer rather than just to give the answer. And then React was a way to structure this design side, and plus to add extra elements. So rather than to have question and answer, maybe I want to have a little bit of planning, some thinking, what I need to do to answer the question. What is missing here is that the first step will be the prompt, right? So what I want the agent to do. So step 0, get the task. Step 1, do some internal planning. Step 2, act, maybe to gather more information. It doesn't have to be the answer by itself, right? So in the React work, I think they plugged it to Wikipedia. So search Apple Remote will give you some data from Wikipedia about Apple Remote. And then the agent would be able to like follow up on another thought, search again, and eventually there's like this special action, which is what kind of answer to give. So the React paper is one of the most important in this line of work. Everything is very new, it's like maybe 4 months old. So we don't know which one are going to be the fundamental papers 10 years from now, but I think React was a pretty good paper in the line. And so the kind of action it had were only these 3, like either search something within Wikipedia or look up a string. And this is like when you do Control F in a page, and then just give the answer. right? It was exciting because now we have this kind of very complex actions that the LLM can take, the agent can take, which have something underneath, like search as Wikipedia and the search engine within Wikipedia. Look up as some grep kind of function and finish as nothing. But we have these more complex sub-actions for the AI to do. And every time it takes one action like search and look up, it's grounding its line of thought in the real world. So this is external information. It's not more within its own feature space, right? So this was the first. Do you guys want to ask questions or clarification as I go, or what kind of format is it?
In general, we have some time later, but I suggest I always suggest, being that this kind of talks are informal one, if you have any question, even now, don't worry, write in the chat, unmute yourself. It's not a problem. I don't think for you, Manuel, as well.
No. But please tell me if there is something in the chat. I don't see it. I think this is a good point to have questions, because it's just going to get more of these, just more complicated and more stuff on top of it. But this is the gist of it. Like, if I had to stop the presentation anytime, this was it, right? This is the core concept.
So maybe if I can ask something. Sorry, I should have raised my hand. So React was essentially the first work about language agents interacting with the web, right?
So I don't know if it's for sure it was not the first, but it's the is the one that I think, if you want to think about it, is like the first step, right? And yes, like it's interacting with Wikipedia, so it's not really the web yet. It's just a very high information, low noise version of it, but it is interacting. Like, we're breaking out of the torch module, right? Before it was still within the GPU. So yes.
Okay.
Was there another question?
Yeah, no. It was actually like something in, like, it was similar to what Arnelia asked, but yeah. But can you just give an example of something? I wanted to know more about the search thing, actually, search and lookup thing. That's all.
Okay, so Wikipedia has some API which, like, when you search something in Wikipedia, right, you can get either the page, and so the agent will just get, you see, this is the first few lines of the page, the Wikipedia page, right? Or if you search for something that doesn't have an entity in the Wikimedia like knowledge base, you would just get the similar results, like this example, you see. So in the first, the agent actually has an it, then the second one, the agent, like the search doesn't return anything. So it gives like suggested other options. And in fact, then the React picks one of them as the new search, right?
Yeah, okay, that's good. Got it.
Yeah, like, so you see here the React itself is thinking, is sensing the world, like it's interacting with the external environment, and then it's reiterating, like remaking another plan. And it's about the thought part is about planning in its mind, or whatever latent space it is, what is a sensible sequence of actions to take, right? It's a feature looking kind of thing.
Okay, thanks, got it.
Yeah. Are there any other questions? Okay, so the follow-up thing, let me see if it has a name. Is it? Yeah, I think it's Ribu. So the next part was about, because we have these phases, maybe it's better to just have specialized sub-modules of the system. Like in React, you just have one big system that has everything together, right? It just has the first part, thought, and then act, thought. So thought, act, and observation, right? But maybe it's better to have subsystems, and they can be specialized, so that the worker can be much more complex. Yeah, in this case, like, they also had another LLM to which you can query, which actually is itself. But the planning part sorry, let me finish. So with the workers, you can have you can start to have very complicated kind of actions, which can be looking externally or in a product, like it can be get me the location of the user, because now we have a specialized part of the network or the agent only thinking about getting more data, getting more evidence. That can be much more complicated. While for the planner, we have variables, and that's like crazy. So the plan here, you can see that it's basically taking the first variable from Wikipedia, put it in E1, evidence 1, and then given the first question, query an LLM with the output from the first one. So this is like asynchronous programming in Python. And then like the third step requires the second one, and then all together for the fourth. So, and everything then gets put together by the solver, which is yet another module which has nothing else except for answering as a job. And all the pieces can be trained independently. So these are, like I was saying, you can have very complex kind of actions. These were the actions they got. So the Wikipedia's before, but then you could also query Google, Wolfram Alpha for some math, another LLM, calculator. And these ones are the exciting ones. So search doc would mean you can search the local documents of the user, right? And location is like get the location of the user that is asking the question. And like, well, let's ignore stock and trade stock because that doesn't sound like a great idea. But like Twitter, Yelp, sending an email, drawing, we are getting to the point where basically you could give access to the Ubuntu shell terminal, and the agent just goes with it. The performance is not, it's nice, but it's not like, we're not done yet. These things are still complicated. And here on the right is an example for this architecture, this method or framework maybe. So the question is, I want to, where is it? Oh, maybe I get it out. It's the question is about being a teacher assistant for Jan LeCun class. And so the plan is step 0, find the email address. So you will need to Google it. Whatever is the output of the Google step, you want to put it into an email, right? And then writes the email. So this is available for now. Then the workers go and solve the problems, go and solve the subtasks, and then the solver puts everything together and gives you the final answer, right? So why I'm excited about this? Because now we're starting to have something which is in the realm of academia, but could very well look like a product. This could be Siri or Google Assistant, right? We're starting to think about access the local documents or access the user location. So up to here, it's just greedy. So the agent tries to do the best thing it can, and that's it. Now we're going to move into like the most powerful methods of decision making that we were using in reinforcement learning up to now. And it's Monte Carlo research. It's the same one that was used like to beat Go and chess, and everybody knows about the DeepMind work. They also use it for many other things like poker. But the extra thing that comes out of this is the ability to have different possible futures in mind, and having planning, a very smart way of planning on top of the LLM. So basically, the original version, you would have a state, which is like what you get to see of the environment right now. The agent would generate some queries, some thinking steps. So it will take a few actions, and then get to the final answer. Maybe it's successful or maybe not. In this way, the agent has different futures and think about them and backpropagates through them. I don't want to go too deeply into this because it's very expensive to run, since now you need to query many times the LLM, which usually the APIs are very slow, or anyway, like these models are huge. So it's not as applicable for you guys, but like this is the end of it. If we can make it work, maybe you heard about the Q-star hype when OpenAI was blowing up. This was the thing people were afraid of. If we can manage to get Monte Carlo research within LLMs in a smart way, that could be very well be yet another like big step in AI, right? And we kind of have this kind of algorithms going. If you want to know more, you can just search for them, or you can just ask me afterwards. But the point here is that the agent can think about alternate futures and also as a model of what's going to happen in response to its own action. Here, the model is the LLM itself. So if I were to do X, what would happen? But it's a way of thinking longer term, but in an explicit way. And we know it works very well. And then there is Lumos. So Lumos is nothing special, to be honest. But it's only but I think it's relevant because it's a way to clarify that prompts are important and structure is important. So the whole point of Lumos is to create this setup where there is some request, some task, and then there is this plan in a very structured way where you write the sub goal, the action you want to take. This is the action, the tool that the agent has to find, has to run, and you write here the result of the first execution of the first tool, and then another sub goal, and then another tool, and then another result. This is a template that is being filled. So if you look at this, and let me skip in the beginning, with respect to the original version, this is way more messy than the other one, right? And like this is a bit misleading because the calculator part, like how does the agent know which are the actions, and we have like fine-tune, or we have fine-tuning steps in the way. So even if the agent knows that this is the only definition of it, sometimes in some setting there is also a little bit of fine-tuning. But still, it's way more compact than we had before, right? Before we had for each of this one an example and so on. So what Lumos did right, like the good results of Lumos was generalization. Like with this, the agents could generalize to a scene task way more nicely than other agents than usually. How are we doing on time? Like how much time do I have? Okay, there's
yeah.
30 minutes left.
You have still 20 minutes.
30 minutes.
Don't
Okay.
worry. Okay.
So yeah, so like when Lumos gives
just to say, don't worry, because you are, in my opinion, going on the perfect velocity because I'm understanding everything. So
okay. I hope everybody else does as well, and really feel free to stop. I have no need to go to the end of the slide. I care about your understanding. So yeah, so the point of Lumos is a way to generalize. Like it shows that better prompts and better thinking of the prompt engineering means things work better. And so it's not just about like many more modules, more training data and everything. It's also about the prompts. And web barrier instead is the environment. It's how we benchmark these agents. So it's a realistic one, which means that you can actually create a product with something that works well on this, and it's valuable. Like we can start thinking about the real world application of this kind of models. Like you can start your own company on top of this kind of stuff. I don't think I have an example. Oh yeah, I do have an example. So this is the kind of task that you have in Web Arena. So it's a data set, but it's also an interactive website. And it's about get me some specific thing from something that really looks like a website, like an e-commerce website, right? These are the applications that the agent can look at. You can go a little bit more in depth. Each task has like a function which is like validate or check solution, and it's whether the agent is done. So it starts from the first page and it has to complete some task, like find me the best way to go from A to B from like this clone of Google Maps. What's the question?
So up until now, we have been doing just single agents, right? One agent interacting with everything.
Yeah, so like AutoGPT had like sub agents, but they were like a thread in programming, right? They were like, go and do this and then give me back the answer. This Woo, what is it here? This guy actually has workers which are like independent because they return variables, even if they're dependent on the previous one. So it is one agent, but it has, let's say it's a multi-threaded agent, right?
I see. So there's like some hierarchy, and this worker is the one that some averages over.
Yeah, it's like there is the boss and or the like. Maybe 5 years ago we would have called it like master and slaves, but now we don't use those words anymore. But you know, that's the kind of thing. You have the core process and then the sub processes.
Okay.
I mean, it's really an implementation detail. You can just do it sequentially. Just that when you have to check the intent, sometimes it's slow. Honestly, the slowest part is still the model itself, like in the forward pass of the transformers. But yeah, so
Thank you.
Thank you for the question. So Web Arena, this is what the agent gets to see, like a picture, but it also gets to see the HTML and an interpretation of the website. And you see here there are the numbers, because this number will be used by the actions to be able to click stuff, to click or scroll around. And so if I want to click the wish list, the agent has to say click, and then 1585, right? Or type, and then you want to type inside something which is typable, which is not here. So this is the kind of point of views. There is yet another one, which is the accessibility focused way of looking at things. That kind of works better in general, but it's harder for a website to be fully accessible compatible, which means that it's not always implemented. So, you know, HTML is fine. The problem with HTML is that nowadays there are like all these shadow DOM or these frames. So you need to do a lot of engineering just to see what you are going to actually render, which means that sometimes the picture is the best, right? Adapt AI is one of these AIs that look at these pictures. It's a big company that does this kind of thing. The stuff I'm working is between HTML or the accessibility version. It depends. Like it depends on what you want to work on. And the kind of actions you can do are these ones. So like do nothing. Maybe the page is still loading. Click stuff. Type. Blah blah blah. Right. So if you remember from who this one, it's you can go crazy with the actions, right? It's just that you don't need, because these tasks are kind of constrained to kind of a single domain. And then talk about going crazy with the actions. So what these guys at Rapid API, which is a platform, it's not a model thing. We're now in the world of libraries and platforms. They basically put together 16,000 APIs with examples, so that this language tool using language models can build on top of them, right? So say you want to do something for movies, their platform will give you like a long list of APIs, and then you get a description. You see like the snippet, the parameters, so the AI can, the LLM or the agent can understand how to use the APIs. So I think this is a little bit too much today, but you know, maybe in 6 months it will be like very normal. So everything is here to be built, right? I think as a field, we did what we always wanted to do, which is to automate everything. And what I would like to see, like us pushing next, like me, you guys, and everybody working in the field, is to take away the digital work from people, so that we can focus back on the real world, and we can have these AI helper agents that will deal with everything that is digital. Like it will be very hard to get from LLMs into the get them into the real world, because there is not enough data. Like LLMs got so good so fast because internet has a lot of text, YouTube has a lot of videos, but figuring out how to control a robot, I'm sure Norman like told you about that, it's a mess of it's much more complex than this. So it should take a little bit for them to take over the real world as well. And that's kind of our world. So I would like to see these kind of AIs to be built to do stuff for us, so we can focus on what we can do best. And and we can really focus on the real world, like look away from the screen, look at people, and on the side you will have the AI doing whatever you need the internet for. Right? And I'm really sure that it's not a question of if this is possible. Like, it's really a question of 6 months or 1 year.
Basically, I want to stress that I strongly agree with this view. I'm basically spending my last 4 or 5 years when I'm invited to talks or also when I'm speaking to younger people about that we need to reconnect with real worlds, with nature, because technology is cool, but on the other side, we are not at all digital, as you mentioned. So I perfectly agree with you. I believe will be the future.
So, like, if you would ask people that know me if this is something I would say, they will be like, "No, you're crazy. Manuel will never say something like that." And the reason is that I think we became digital beings because that's the best thing to do, right? Because internet gave us a lot, gave us the ability to learn, to interact, and to work, and collaborate with others. But I really hope the next step would be those things being automated away from us, because we need the digital world. But maybe we don't need to be the ones working on it, right? It can be an underlying layer, like in the same way we don't use telephone calls anymore. But there's still an underlying layer, well, if you want to have very slow internet of communication. But yeah, I think this is what should be happening in the next 5 years, and I'm happy that you agree. So yeah, this is what I'm going to build next. What I'm going to build I'm going to start a company based on that, on everything I've been talking about getting people away from computers and back into the real world, and computers into computers, so they can help us. So we can talk about that more in the Q&A if you have questions. But overall, I mean, that's it. Like, the last paper that I know of was published 5 days ago, and this is kind of what it is about. Like, the 5 days ago one is basically this one with better Google search, Google query system, because that was internally from Google. I think this is from CMU. I don't know, but yeah, this is where we are right now. Do you have questions?
Prompt engineering, right? Also prompt engineering in your field.
It's more like everything, It's like we are too early to say that every single piece of the question is not valid. One thing that doesn't come out from this talk is how slow GPT-4 APIs are. If you look at an agent interacting with the web with GPT-4 APIs, it's so boring because it's slow. You're like, computers are supposed to be fast, yes, but the forward pass of the GPT-4 architecture is so slow that the speeds at which we are used to we're nowhere close to that, right? People are way faster right now. And even when you play with ChatGPT, right? When you get an answer, you need to wait. Like, you start thinking about other things. You check your telephone. So even the lower level, like the hardware level, is not. We still have to keep it in mind. We need to keep in mind all the abstraction layers from the atoms to the bits and to the people. So I don't think we are yet to the point where we can say just this part. It's everything together, right? And it kind of sucks because you need to have a lot of stuff in your mind as you develop this stuff. But it's good because that's our job for now. Yeah. Do you have questions about, are you guys using this kind of agents? Or are you doing prompt engineering? What this kind of research, what this kind of research also shows us is that a good prompt is something that is very valuable. Like, I think you can get 30-40% more accuracy on average just by having a good prompt. But it takes some time. There is a website about prompt engineering, which is not too bad. I don't know which one, but if you Google prompt engineering website, just prompt engineering, you should get it. So if you want to, if you don't have a question, we can go to the no recorded phase, or unless there are other questions.